This is Mr. Craig, and the purpose of this video is to explain question number 5 on, I believe it's day 14's examples. Number 5 says a stock solution containing barium plus 2 ions was prepared by dissolving 23 grams of pure barium metal in nitric acid and diluting to a final volume of 2 liters. Calculate the concentrations of barium ions in the stock solution and the diluted solution if 125 milliliters of the stock solution was diluted to a final volume of 500 milliliters. Alright, the first thing that we need to do is we have to prepare our stock solution. Unlike with the other questions where we knew how much of the dilute we were going to make and at what concentration, this problem is saying that we have a mass amount and we're preparing a stock solution. And then we're going to take some of that stock and put it in a brand new volumetric flask and dilute it down. So the first thing that we need to do is determine what the concentration of the stock is. So we need to, first of all, create a stock solution from the information given here. So the question said that we had 23 grams of barium metal dissolved in nitric acid. Now in this question, you did not receive any information about the volume of the nitric acid, which is okay, because if you do or you don't, you ignore it. In other words, when we find concentration or molarity, the only thing that we care about is the total volume or the final volume at the end of the question, not what goes into the question or not what volumes go in to make this liquid. It's only the final volume at the very end. Also, the barium ions are then placed in a volumetric flask and water is added to make a 2-liter solution. So knowing all this information here, the first thing that we need to do with the grams of barium is first of all convert to moles. We have to find out what the concentration is, and concentration is moles per liter or molarity. So we'll go ahead and calculate the 23 grams of barium, convert that into moles. Now one thing that you'll notice is I have 23 grams of barium all by itself here because that's a metal before it's actually dissolved in the nitric acid, and then when we finish we've got our barium plus 2. Now the nice thing is, even though 2 electrons have been removed and put into solution somewhere, we don't know where it's at, we don't care, the molar mass still remains the same, so we don't need to worry about, well, we lost 2 electrons, what's the molar mass now going to be? So not the concentration, but the number of moles of the barium plus 2 ions is 0.1675 moles. Once we know the number of moles, we can determine the concentration or the molarity of this stock. So it said that we want to make a 2-liter solution, so we're going to take our number of moles and divide it by the total volume, and in this case here we get a 0.08374 molar solution or moles per liter. So we finished the first part of the question and we have our stock solution. So we have a 0.08374 molar stock solution. What the question now asks us to do is to take 125 milliliters of that stock solution and we're going to prepare a dilute solution. So we want to now create a dilute solution from the stock that we just created. So here's the information that we know. We know our concentration. We know we're going to take 125 mils of the stock and then we're going to dilute that to a total volume of 500 milliliters. Then we want to calculate the concentration of the molarity for the dilute solution. So here's what we're going to do. We're going to actually, we just made our stock solution, so we're going to take 125 milliliters of that stock and put it in a little beaker. We're going to measure out the volume. In this case, the concentrations are the same, but we know what the volume is, but we don't know how many moles we actually have within the little beaker. We know that we have 125 milliliters. We know what the concentration is from our stock. So what we need to do next is calculate the number of moles that are in that 125 milliliters from the stock solution. So we're going to start with the volume. If you know the volume and the molarity, always start with the volume. So we're going to convert those milliliters into liters and then multiply that times the molarity, which the volume cancels out, and we're left with just our volume here. So we've got a 0.01047 moles in our little beaker here. Okay, that's how much we actually took from the stock solution. Regardless of how much water we add to the brand new volumetric flask, the number of moles will not change. That's a huge concept. You need to realize that when we're looking at a dilute solution, no matter how much water you add, the moles remain the same. Molarity is going to change, but moles will not. Alright, so now we need to calculate the molarity of our new dilute solution after we've added 500 milliliters. So, we just calculated our number of moles, divided by the total volume, which in this case is 500 milliliters. Do not be concerned that we added, 375 milliliters of water. We don't care. All we care about is the final volume. So our new molarity is a 0.02093 molarity. Alright, here's the process that we used to actually do this. We actually had our little beaker that we poured into our new volumetric flask, so 125 mils from the stock solution. Then we're going to add just enough water to dilute this down to 500 mils. Now, once we do all that, you'll notice that the concentrations change. Hopefully you realize that a concentrated or a stock solution will have a higher concentration than a dilute solution. So when you're doing these calculations and you come up with your molarities or your concentrations, if your molarity for your dilute solution is higher than your stock, you did something wrong. You need to go back and check your calculations. If you have any questions, by all means, email me or let me know. I hope this video has helped.